Hello everyone, welcome back to the continuation of our series on systems of equations in application. So today we're going to be looking at mixture problems. I'm going to call this kind of level 1 mixture problems. In this situation we're starting with two mixtures and we're combining them together to make a third. We're kind of starting at ground zero. We can add as much of A to as much of B as we want. We haven't been given an initial amount of A or an initial amount of B. Both of those quantities are totally within our control. When we see some examples of this, and when you look at the video for the second type, the level 2 of mixture problems, hopefully you'll be able to tell the difference between those. So let's look at our first example and go from there. So it says solution A is 30% alcohol and solution B is 75% alcohol. How much of each should be mixed together to make 100 liters of a solution that is 50% alcohol? So first let's start off by defining what our variables are, and it's asking how much of each. So we've got solution A, so to make it a little bit easier to follow, I'm going to make little a equals the liters of solution A. And let's let little b equal the liters of solution B. Great. So we are trying to make 100 liters of the final solution. So we do know that our first equation is going to be pretty straightforward, that A plus B, the liters of each of them, must be 100. Now, we are adding different concentrations. So let's do a little bit of some mental math here just to see if we can estimate where our answer should be. So we've got 30% alcohol in solution A and 75% alcohol in solution B. So if we compare that to where we want to get in the final answer, we notice that 50% is 20 away from solution A, but 25 away from solution B. So the final answer is closer to solution A. So that should lead us to recognize that we're going to need more of solution A than solution B. So in our final answer, hopefully we get an A value that is more than half, so more than 50, because that's more than half of our liters. So that's going to put us just some mental checking to make sure we're in the right frame of mind. So however much of solution A we add, we're going to basically multiply it by its concentration. Now, we're going to take that 30% and we're going to turn it into its decimal equivalent. So 30% would be 0.3. So 0.3 times the liters of A would give us how much of the alcohol we get from solution A. And then from B, that's 0.75 times B. So if we take the alcohol we get from A and the alcohol we get from B, that should equal the total alcohol, not the total liters. So it's not going to equal 100, and 50% isn't an amount, it's a percentage. So what we really need is to have the amount of alcohol 50% of 100. So I'm going to write that down. 50% of 100 would be 0.5 times 100. So this is an equation for basically alcohol. The amount of alcohol from A plus the amount of alcohol from B is going to give us the amount of alcohol total at the end. So this is our two equations, and so we can now go ahead and solve a system of equations. Now, I would prefer to clean up this second equation. So I'm going to go ahead and multiply to get rid of decimals. So I'm going to multiply both sides by 100. So if I multiply this side by 100, I get 30A plus 75B equals, well, this was really 50, and 50 times 100 is 5,000. Great, so that's an equation. We also have the other equation here. Let's go ahead and solve this by a substitution this time. So I'm going to go ahead and take this equation, and I'm going to subtract B from both sides. So A is equal to 100 minus B. So if that's A, I can go ahead and plug that into our equation where I see A. So 30 times 100 minus B plus 75B equals 5,000. Great. So we can go ahead and now solve because we've got one equation with one variable. So 3,000 minus 30b plus 75b equals 5,000. And we can combine our like terms here. So we've got 3,000 plus 45b equals 5,000. And we can subtract 3,000 from both sides. And we get 45b equals 2,000. Let me carry that up here for us. So 45b equals 2,000. We can divide both sides by 45, and we get that b is equal to either 400/9 is the reduced fraction. That's also equivalent to 44.4 repeating. Right away, I'm happy because I got b, the second solution, as less than 50. So a is going to end up being more than 50. So we want to go ahead and find a. So we remember that a plus b is 100. So a plus, I'm going to go ahead with the improper fraction here, 400/9 is equal to 100. So just to make my life easier, I'm going to go ahead and multiply both sides of this equation by 9. So 9a plus 400 equals 900. Subtract 400 from both sides. 9a equals 500. And if I divide both sides by 9, I get a is 500/9, or 55.5 repeating. Okay, so let's go ahead and answer the question before we wrap this up. So we need 55.5 repeating liters of solution A and 44.4 repeating liters of solution B. Let's look at another example. It will look a little bit different, and we want to make sure we recognize them as the same problem. So that one we were literally dealing with like chemical mixtures. But a mixture doesn't have to be acids, bases, and liquids. We can mix physical things, like in this example, a mixture of nuts. So here we have cashews sell for $8 per pound, and pecans sell for $9 per pound. How many pounds of each should be mixed together to make a 10-pound mix worth $84? So let's start by getting our variables defined. We want to know how much of each, how many pounds of each. So let's let C equal the pounds of cashews, and we'll let P be the pounds of pecans, however you pronounce it. Great, so we know that we must make a 10-pound mixture, and that is part of our equation, our first equation. So P plus C is equal to 10. However much of the pecans and the cashews we add together must give us 10 total. So the other part is that the whole mixture must be worth $84. So each pound of cashews is $8, and each pound of pecans is $9. So if we take the $8 times the, let me write them in the right order here. So $9 times the pecans, I'll keep those lined up together. And $8 times the cashews, I'll keep those lined up together. So that's the amount that the pecans would cost and the amount that the cashews would cost. Together, those must be $84. Great. So we've created an equation for the cost and an equation for the pounds. So we have a system of equations, and we can go ahead and solve that. Since these are both written in standard form, it looks like a great situation to go ahead and solve by elimination. I'm going to go ahead and choose to multiply the first equation, both left and right, by -8. I'll write that down below. So -8p minus 8c equals -80. Great, that makes a nice equation. P equals 4. We don't have to do any other secondary steps to solve. We right away got that there's 4 pounds of pecans. So we know that pecans plus cashews is 10, so 4 plus C equals 10, and C must equal 6. So So we'll finish by answering the question that the mixture needs 6 pounds of cashews and 4 pounds of pecans. Great. Let's look at one other example, and we're going to go, once we finish that, compare it to these other two. You'll see some similarities and differences between the first two examples we have here. Okay, so for this next one, we've got a coffee shop mixes Brazilian coffee worth $5 per pound with Turkish coffee worth $8 per pound. The mixture is to sell for $7 per pound. So how much of each type of coffee should we be used to make a mixture of 300 pounds? Okay, so again, we're asked to find out how much of each mixture do we need. So let's go ahead and define our variables. So we can go with B for the pounds of Brazilian coffee. And we'll go with T equals the pounds of Turkish coffee. Okay, so we know that there must be 300 pounds of the mixture all told. So B plus T equals 300. Great. The next part is that the Brazilian coffee costs $5 per pound and the Turkish is $8 per pound. The final mixture is $7 per pound. So if you look at that, clearly it's not going to be this. It's not going to be that 5B plus 8T equals 7. That wouldn't make any sense. We couldn't even have a pound of each of them to make 7, let alone have them combined to 300 pounds. So this differs from the problem 28 here, where they right away told us the total cost of the whole 10 pounds. They didn't tell us the cost of the 300 pounds here. They told us that each pound would cost $7. It's kind of similar to the first example with the solutions, where they didn't tell us how much alcohol there was. They told us the percentage of the alcohol. So we had to take that percentage, multiply it by the number of liters. Similarly here, we need to take that $7 and multiply it by the number of pounds of the coffee that we have. So that 7 needs to be multiplied by the 300 here. Okay, but ultimately now we have a system of equations that we can solve. And let's go ahead and solve this by elimination. Let's go ahead and multiply this first equation. I'm going to choose to multiply it by -5 and eliminate b. So we multiply the first equation by -5 and we get -5b minus 5t equals -1500. Great. We can go ahead and add our equations. B's cancel. We have 3t. This line here was equal to 2,100, 7 times 300. And so 2,100 and -1500 gives us 600. So we can divide both sides by 3, and we'll get that t is equal to 200. So that's the amount of pounds of the Turkish coffee. So pretty easy to go from the to find the Brazilian coffee. So B plus 200 equals 300. So B equals 100. And like we did in earlier problems, we can kind of mentally see that makes sense. Since the Brazilian was $5 and the Turkish was $8, but we're trying to get $7, so the end goal, $7, is closer to the Turkish coffee. So it makes sense that we have more of the Turkish coffee than the Brazilian coffee. So let's just go ahead and finish this off with a nice summative sentence that says we need 100 pounds of Brazilian coffee and 200 pounds of Turkish coffee. Okay, So thanks for joining us again for this application of systems of equations. Continue to check out our other videos on other applications of systems.